Our main focus for today, we are going to look at physics. We are going to look at Newton's law of universal. This is lesson 104. Let us start. We have one of the past question papers. We are going to answer it. Now the scenario says gravitational force exists between the sun and the earth. The mass of the sun is 330,000 times greater than that of the earth. The distance between their centers of the sun and the earth is 1.38 times 10 to the power 9 meters. Calculate the gravitational force that the sun exerts on the earth. So this is the scenario. We have the mass and the sun. Now according to the scenario, it's saying the distance between them is 1.38 times 10 to the power 9 meters. And then the mass of the earth, we know that actually according to the scenario, the mass of the sun it's equals to 330,000 times the mass of the earth. So if we know the mass of the earth, we actually know the mass of the sun. So the mass of the earth is 5.98 times 10 to the power 24 kg. So in order to find the mass of the sun, we need to multiply this number by 380,000, and then that will be the mass of the sun. So multiplying this 5.98 times 10 to the power 24 with 380,000, we find that the mass of the sun is actually 1.97 times 10 to the power 30 kg. So with this information, we can actually answer the question. Now we start by writing our equation. So according to the data, we are looking for this. We have this is a constant, universal gravitational constant. We have the mass m1, m2, and then we have the distance. So we can go ahead and substitute and actually find the answer. So its F is equals to 6.67 times 10 to the power negative 11. That is the magnitude of G. And then our m1 is 5.98 times 10 to the power 24. And then m2 is 1.97 times 10 to the power 30, all over the distance between their centers is 1.38 times 10 to the power 9 squared. In most cases, learners, they make a mistake by not putting this power 2. Then you must know that everything will become wrong. So punching this on the calculator, we find that our gravitational force is 4.126 times 10 to the power 26 Newton attraction. So this is the answer. Let us quickly go to the next question. How will the gravitational force that the earth exerts on the sun compare to the answer to question 5.2? Write only greater than, less than, or equals to. Give a reason. Now for this question, we are going to use Newton's third law, which is action-reaction pair. So if suppose we have our earth and this is our sun, If the earth is exerting a force to the sun, which is the one we got, 4.126 times 10 to the power 26 newtons, the sun will also exert the very same force but oppositely directed to the earth. So the actual answer for this one, it will be equals to, the reason why, we can give a reason based on Newton's third law, that is action reaction pair. Now that's it for this lesson video. This is Bahula SJ. Thank you very much.